Okay, Assalamualaikum warahmatullahi wabarakatuh. My name is Amirul Nawaf bin Isa and my ID is MA17222. Today I will be talking about Lab 5 Pelton wheel turbine for our fluids mechanics lab. Okay, so these are the group members listed for this particular lab. Okay, and today this is my ID, my name, and I will be talking about chapter 1, which is introduction. Okay, so for a Pelton wheel, what is a Pelton wheel? A Pelton turbine, sometimes known as a Pelton wheel, is a form of hydro turbine. More specifically, an impulse turbine that is commonly seen in a hydroelectric plant. So here we can see an example of a hydroelectric plant which has a wheel turbine. Okay, so for this lab, the problem statement is the problem of this experiment is to maximize the efficiency of the water jet when it hits the bucket in the middle. The next one is the fully open nozzle will then be the only data taken into account. Finally, in order for the water jet to be hit, the nozzle must be properly aligned with the bucket and the water storage tank and flow control valve must be in a vertical position. So these are the problem statement for this lab. Okay, so for the objective is to investigate the link between the Pelton wheel turbine's power and the efficiency at various rotational speeds. Another one is to determine the turbine's performance and power production when the pressure and flow rate are constant but the rotational speeds varies. Okay, so the scope of this experiment is to conduct a literature review on the history of the Pelton wheel and comprehend its concept and operating mechanism, to conduct an experiment investigation in the lab using the data provided, and to conduct an analysis of the data gathered based on the lab results. Okay, so this is the chapter 2, which is literature review. It will also be presented by me, Amirul Nawaf bin Isa, MID is MA17222. Okay, this is a wheel design. This is a general design of a Pelton turbine, Pelton wheel. So the cup-shaped blades known as the buckets are uniformly distributed around the circumference of this circular disc. As a result of the impact of the water jets on the buckets, the turbine spins. So you can see here, this is the general design. Okay, so this is how it works, the mechanism of the Pelton turbine. A Pelton turbine is quite simple to operate. High velocity water jets come from the nozzles that surround the turbine in this type of turbine. Number two is these nozzles are positioned so that the water jet hits the bucket at splitters. High pressure water such as that falling from high heights is pushed through the nozzles of the atmospheric pressure to form the high speed water jets. And this produces electricity when the wheel turns. That is all from me. Thank you.
Thank you to my colleague who has already presented chapter 1 and chapter 2. So it's my turn. I'm Kuglan Lakimani, I'm MA18098. So I would like to start the presentation in chapter 3, method and procedure. So the next slide. So first thing is I would like to touch about is about the experiment apparatus, which consists of 4 apparatus, which is Pelton turbine, hydraulic bench, data measurement, data acquisition, and tachometer. So this is the schematic diagram of Pelton wheel and hydraulic bench, which can be seen in our lab for our fluid lab. So this is the first image of the Pelton wheel. The second image is the hydraulic bench. So these are the components of the Pelton wheel and hydraulic bench. Then this is experiment setup, where here there is a spear controller, and second picture is there is a pressure sensor. Third picture is flow sensor, and the fourth picture is tachometer, where we set up the tachometer behind the Pelton wheel. Then and we release the spear, and then we can adjust the spear by releasing the adjustable place for the spear. So the experiment procedure. So there's 9 steps in total. So first thing is all the connections of the water checked so that there's no leakage. Then second one is the spear valve is completely closed. Then the third thing is begin the hydraulic bench and gradually open the control valve while opening the spear controller until the bench flow is at maximum and the spear valve is fully open. Fourth one is the hydraulic bench is used to measure the initial flow reference. The inlet pressure is noted. Then the tachometer is used to measure the maximum of the turbine. The tachometer is put against the clear glass at the back of the turbine and it's used to detect the reflection sticker on the drum. Then the average rotational speed is estimated over the course of few seconds. Then the volumetric flow rate is determined by plugging up the drain and the bottom of the bench with the drain column. And the water line on the side of the bench is observed. The timer is started when the water line reaches 0 liters and it is stopped when it reaches 10 liters. The volumetric flow rate is obtained by dividing the 10 liters. The experiment is repeated with reducing the RPM, so we can get the proper data by reducing the RPM. Thank you so much. That's all from me.
Next, we will continue on chapter 4, which is result graph and discussion. As you can see, this is the result for the experiment. For the left side is the fully open, which is constant pressure 0.2 bar and constant Q at 30.9 liter per minute. For the right side, this is the result for power curve. Pressure at 0.2 bar, Q equals to 31.5 liter per minute. Next, we go on the graph and discussion. This is the graph for the first experiment for the fully open, constant at 0.2 bar and constant Q at 30.9 liter per minute. As we can see on the graph of efficiency versus rotational speed for fully open is shown in the figure. It can be noticed on the graph that the line is increasing and then decreasing. The value of efficiency decrease when the value of pressure and Q constant, which is constant 0.2 bar and constant 30.91 liter per minute, while the value of rotational speed increase. The efficiency of a machine is inversely related to its rotational speed. When the rotating speed is 534 rpm, the greatest efficiency value is 61%, and when the rotational speed is 286 rpm, the lowest efficiency value is 42%. Next, we continue on the graph of power out versus rotational speed for the second experiment. For the power curve, it can be noticed on the graph that the line is increasing and then it is gradually decreasing when the pressure and Q constant are set at 0.2 bar and 31.5 liter per minute. The power out decreases while the rotating speed increase. When the rotational speed is set to 760 rpm, the lowest value of power out is 0. When the rotating speed is 515 rpm, the highest value of power output is 2.9 watt.
Assalamualaikum warahmatullahi wabarakatuh. Okay, my name is Muhammad Iqbal bin Muhammad Ali. Okay, for the conclusion, we may deduce from this experiment that when the diameter of water flow leaving the nozzle is limited, increasing rotational speed does not always imply higher power because the water flow is moving at a high velocity. Allowing the Pelton wheel to spin at a high rate increase the torque and strain on the wheel. As a result, production capacity will increase and output will significantly improve. Okay, that's all for me. Thank you.